Bismillahirrahmanirrahim. Good afternoon, guys. Today we'll try to illustrate the important information about the experiment number 5. Experiment number 5 today is the Hooke's law. How we can, let me go directly to the purpose. After that, let's discuss the important information. We have important questions. Let me go to the next. Why today the Hooke's law is important experiment and why is related with your department. Actually, at previous lecture, I was talking about skeleton human lecture. We said something about at some limitation, your bone will be broken. And I illustrate and use this information, this curve too much to illustrate a lot of information. I use this curve to illustrate all of the limitation points before broken point. The first one region, one state, or I can say that at elastic region, it was OA or 0A. This region was act as any spring, okay? That's mean your bone when some stress applied on your bone, the first state resistivity from your bone will be at elastic region, like this curve illustrates to us at 0A, will act like any spring, okay? Because that, today I will learn you how we can determine the constant force to any spring, okay? And we will illustrate after that what that's mean, what this minus at this function, F spring equal minus Kx. K is the constant force to the spring, is different from spring to another. The same this K, your bone, it has. X, it's the extension, the delta L, the delta length. Okay? Before explaining what this minus mean, let's come back to the purpose. It's important thing today in your experiment. The purpose here, we have two purposes today. The first one is to verify Hooke's law, what that's mean, what's its function, what all of these elements are meaning to determine. The second thing is to determine the force constant, that's mean K. And like I said before, it's different from spring to another. The elasticity, that's in flexibility, force of spring is proportional with the vertical extension. The flexibility to the spring to your bone, it's proportional with the vertical extension with delta L, delta length, due to the mass attached in your bone because the potential is applied. Some force, some resistivity, some force applied in your bone. The same thing, the same situation with the spring when some mass is attached on it. Now let's say what is the F? F is the force and its unit is Newton. K is the constant force to the spring. X is or E. Actually, I prepared E. E from extension. It's easier. But up to you, you can use X of spring and its unit is N, that's mean meter. Now let's discuss what is this minus mean. This minus is related to the opposite relation between the restoring force and with the force, the mass attached on the spring. The mass which attached on the spring, it's up to down. The restoring force, it's down to up. The minus out the Hooke's law means this restoring force due to the spring elasticity in the opposite direction to the force, which case this displacement. And this image illustrates to us that very well. Now you have this table, the mass. Actually, we will work on different 5 or 6 masses. I will start from 0 until 500. Step by step, I will increase 100 grams, okay? After that, you will learn how you can calculate the force at Newton units. After that, you will calculate the length of the spring and extension of the spring. In your curve, you must determine the slope. In your curve, we will work on these 2 columns, the force in Newton and the extension of the spring. Extension of the spring will be at y-axis, weight or force at Newton will be at x-axis. Now let's take a look how we can calculate this mass to fall this force at Newton unit. We know the force equal mass multiple acceleration. 1 unit is equal to 1 kilogram meter per second square, or by another words, 1 Newton of force is the force required to accelerate an object with a mass of 1 kilogram to 1 meter at specific time. The specific time is per second. Okay, 1 kilogram F equal the acceleration multiple in Newton. By that, Newton equal 1000 gram F divided on acceleration 9.81. By that, the result by using my function calculator was 101.936. Here from Google, it's approximately the same. Maybe by use better calculator, I don't know. By that, multiple to be 2 Newton equal 3 Newton equal. We will use approximately results to make your mission be easier. How? 101 dot something will be 100, 200, 300, 400, 500. To anyone want ask about how you can convert the gram to Newton, we use this way from these 2 functions. Here, that means I have 1 Newton until the last step was 5 Newton. By that, length of the spring, it was 6 centimeters, the original length without any external force, okay, without any attached mass. Here, you must determine the extension of the spring. Okay, that's mean this slide is important because the question is you must know every word in this question, what it means. According to the column below, this column below, determine the spring constant. That's mean K. Okay, here and at the last slide, we will learn together what that's mean, this K. It's not the spring constant, it has some another meaning. By that, you will calculate the extension of the spring to can plot the y-axis. X-axis is ready and you learned how you can determine it. Actually, in the exam, I will not write the 0, 1, 2, 3, 4. Just I will write 100, 200 from 0 to 500 gram. without the force in Newton, because that will be your mission. I explained to you how you can convert from gram to Newton. That means you will calculate all of these two columns, the force in Newton and extension of the spring. Now let's discuss how you can complete and solve this question to can determine the K constant. Here, 9, the new length with the original one, that's mean 9 minus 6 will equal 4. Here, with no change, with no new length, that's mean 6 minus the same will equal 0. But here the situation is different. 9 cm minus 4, the new length minus the original length equal 4 cm. To convert, must convert it to meter, to be 0.04 meter. The same thing with the other, and convert it to be at meter. Here, extension at y-axis, weight or force at Newton at x-axis. Actually, I take the picture to my notebook because that I think it will be easier to you to can know how you can divide this paper by plotting x-axis and y-axis. Gradient slope equal slope or gradient, it's the same meaning, the same word, equal delta y on delta x, that's mean delta extension on delta weight. Before that, we must plot our line to can determine which points we will depend on it to can calculate the slope. From the curve, I wrote all of these numbers at extension. Here, let me start from x-axis at the force at Newton, it's easier. Every 2 centimeters, I put 1 Newton. By this way, by this function, I divided x-axis. After that, I used every centimeter, it was equal 4 centimeter extension, okay? Until to 24. After that, between them, I divided my numbers. 8.8, 13.1, 17.6, 22.2. Okay, now it's easier, I think, because the most difficult thing to the students is how you can divide it, the x-axis and y-axis. After that, the other, it's easier. Now we can calculate the slope. I selected these 2 points. Actually, I had just one irregular point out the line. It doesn't matter. Must be most of the half of the numbers in the line. By using most of the half of these numbers to plot them my line. After that, I selected 2 points in the line. It's a condition, it's important. I can select the irregular point to determine my slope. By that, I selected these 2 points, or you can select another, doesn't matter. 17.6 minus 8.8 divided on 4 minus 2. I have 0.044 is the slope. Now let's think about that. Let's think about that. How I can calculate the K. At the previous slides, I said the force equal K constant multiple extension. This function, let's focus on it. After that, from this function, we can say K equal force divided the extension. Force at any unit divided on extension with meter unit. Let's say it's equation number 2. Slope equal what? Equal delta y divided on delta x. What that mean here? That means delta extension at meter divided on delta force at Newton. Let's take a look here. Delta extension divided on delta force. And let's take a look to equation number 2. That means it's reverse bias. Slope equal reverse bias decay. By that, I can say K equal 1 divided on slope. By that, I have 22.727 Newton divided on meter. Newton divided on meter. Because the slope, the K, it's opposite of the slope. Okay? By that, we learned how we can determine, calculate the K constant and its unit from where. Let's take another picture. Actually, I take this picture from your whiteboard. I plotted this curve by using the same numbers at the whiteboard, and I plotted my line. But here at whiteboard, I had 2 irregular points because, let's say, at whiteboard, the situation is difficult more than at the regular paper. Now I think everything is clear. Here extension at y-axis, f at x-axis. By that, I determined my slope and determined the spring constant. Now let's discuss what that's mean. K here mean, what does mean? 22 something number Newton divided on meter. That's mean I have, let me use my mouse pointer, I have this force to can extend my spring to 1 meter. I have this force to extend my spring to 1 meter. It's a standard number, okay? But this K is different from spring to another, okay? The same K, but with another number you have in your bone. From the curve, the relation between the extension, here the discussion about the previous curve about extension at y-axis and force at x-axis. From the curve, the relation between extension, m, meter, and the force Newton is linear relation, and that means by increasing in extension, the force will increase to y because it's linear relation. Okay, that's it. These few words, I think they are simple and will be easier to you to write it in the exam before finished your curve. Okay. Our lecture is done. Thank you about your watching, your listening. Have a good day and see you in the next lecture. Bismillah.